What if your app could update instantly without refreshing, without polling, without reloading, without wasting resources? Think like live chat, stock prices, notifications, all happening in the real time. But here is the real question. Should you use server sent events or WebSocket? Because these are the two technologies in the same direction. So let's try to understand what are these and how they can help us. So welcome back. Today we are diving into the two powerful technologies behind real-time web applications, server sent events and the WebSockets. By the end of this video, you will know how they works with the simple demo examples. Server sent events is a one-way communication channel. That means server sends the updates to the client continuously. It's like a stock prices. You are looking at the dashboard and the stock prices are pushed from the server to the client and you see the live dashboards getting updated. What is a WebSocket? WebSocket takes things to the next level because it provides a full duplex communication. That means the client and server can send messages anytime. It's like a phone call instead of broadcast. Server sent event is a broadcast from server to the client, but it's a full duplex communication in the WebSocket. It provides a persistent connection, real-time two-way communication, extremely low latency. So let's dive into the SSE server sent events and the WebSocket, how they works, and what are their use cases, and how they can help us in building the applications. So server sent events and a WebSocket. So let's take a quick overview. What are these and how they works? So direction is server to client only for SSE, but WebSocket is fully bidirectional. It is auto reconnect, SSE built in, manual implementation you have to do, data formats, and all these how they communicate and how the data exchange. So when should you use SSE? Server pushes the updates to the client. Simple text or JSON data streams you can send from server to the client. It leverages HTTP to multiplexing. So WebSocket, it's bidirectional. That means bidirectional communication is needed. It can send a binary data, file, image, audio. It uses ultra low latency requirement. That means it is more performant. So SSE deep dive, like in a server sent events, what we do is at the NestJS or at Express TypeScript, what we do is we write a simple endpoint, right? And at the client side, we just call the new event source to that URL. And whenever the message is pushed from server, this on message callback gets triggered. Similarly, how it happens in the WebSocket. WebSocket, I mean, if you are doing the WebSocket with the NestJS, you can just use these decorators. And then at the client side, you just use a socket IO instance and socket.emit, socket.on. Socket.emit means you are sending the event to the server. Socket.on when you are receiving the message from server to client. So this is how this works. So performance wise, memory and connection, SSE 10 KB, WebSocket 15 KB. Latency is low for the WebSocket. Message per second in the WebSocket you can send 100,000, in SSE 50,000, right? Both are built on top of the same stack or same technologies. HTTP 1.0, unlimited, multiple tabs. They share the connections. Shared limit will be independent to the tabs, right? So this is like a particular differences. Now, what are the benchmark? How can we identify the benchmark and their performance? So what are the live use cases? Server sent events, live dashboards like stock price, server metrics, analytics, notifications, progress updates. Let's say you trigger some action on the UI and now you are waiting for the callback to return and update the state. In that case, you can just use the server sent events because server is taking some time to perform that asynchronous operations. So you can send a server sent events so that will tell UI, okay, that task has been done. Now you can perform the action. WebSocket is duplex like a chat application, Slack or any kind of chat, multiplayer games, collaborative editing and all. In that case, all these things are used. So let's take a look onto the demo. Hi everyone, so let's take a look onto simple demo example. So we are talking about SSE server sent events and the WebSocket. So server sent events uses the HTTP protocol where WebSocket use WS or WSS. So let's take a look onto different examples. There are two NestJS applications. Both are running on different ports. So a simple example for SSE is like a simple NestJS application where we are writing this controller. And what it is doing, if you see this counter endpoint is returning some data every second, like interval of 1 second. So what we need to do at the client side, we just need to do a new event source, event counter, and then you just need to connect, and all the messages which you are getting from this event source will be, we can show it on the console log, or here this is how we are adding a data. Or you can also add an event like, okay, event source dot add event listener stock update, and you will just parse it and show it in anywhere. So SSE, server sent events, are simple HTTP event type. Different event names we can use for filtering. On the other hand, the WebSocket. So WebSocket is kind of a simple chat application where user can join room, send a message, or remove from the chat group and all those things. So here we have just a simple controller gateway, WebSocket gateway, and here we have a, we have these different endpoints, handle join room, so which is allowing client to join the room, and whenever the user is joined, we will just emit the event user joined, right? And this is how we can subscribe the message. Whenever the any user enters the chat message, then we can emit the message to the target user with this. So it's like a simple chat, and this is how we can add it in the client. This is WebSocket IO and IO.emit join room. Okay, whenever you join the room with the username and password, you can emit it, or you can listen to the messages which are coming. Socket.on message, when there is a chat message received by you, or a send message, socket.emit. So there are two events we are sending from the client side, join room or a message. First I will join the room, and then I will start sending the messages. WebSocket is bi-directional. So let's take a look on to the demo example. So let's take a look onto this example. So this is a counter stream. What I will do is, on this counter, I will hit connect, right? So this is the endpoint I'm hitting. Localhost 3000 event counter. This is a event source, and you can see the event stream coming now. This is what the server is sending us in a single flow. Server is sending data to the client. That's it. It is keep sending me the count, and that count, because on the client side I'm just doing a on message, and I'm showing all the count. Server time, if I connect, what it will do is, it is hitting this endpoint, event time, and I think it is just sending an event stream of the timestamp. That's it. Notifications, these are just a different endpoints in the application. Notification API, even event notification. I think event notifications will be coming randomly, like, okay, new user joined, new email received, and all the event logs we are showing here. All the event logs related to the counter, related to the server time, related to the notification. You can connect to this mock stocks endpoint, which will send me the random event stream about the updates. So what is happening? I'm sending action from the UI, and a server is sending the updates, the concurrent updates, and in the stream, event stream, and we are subscribing. We are listening to that event stream, and we are updating the UI on the fly without reloading the page, right? This is how I'm starting the task ID, and I can see that the complete progress, and this is the whole event log, right? So this is how you can connect to the multiple event stream. You can see the notifications, stocks, tasks, and I can also connect to the counter. So all these, you can see I'm connected to the 4 event stream, and I keep receiving the data from them. And the code is very much simple. I just wrote a controller with the SSE annotation. So this is pretty much simple code we have. Events is the root controller route. In that we have a counter, stocks, progress, notifications. It is just using this observable operator interval, and every 3 seconds it is just emitting this data. Okay, these are server sent events. Like time, it is sending you the time with the time zone information, heartbeat, health check. All these endpoints are there. So this is just only a single controller. It is taking care of all those things. So code example is pretty much simple. If you see in the main.ts, we have created application, app module, event controller. I just have an event controller with the SSE annotation, SSE counter, SSE stocks, and SSE is the part of the common NestJS common. We didn't include anything specific, right? But in the index.html, this is where our client stays, and this is where we are creating the event source object. This is event source for notification, this is event source for the time. For all these different actions, we have this event source object, and then we are handling on message events on all of them, on error and on message event, all on the event source objects, because we have multiple APIs tracking the progress, stock status, or connect, server time, counter status, and all. And we just have these two callbacks on every event source object, on message or on error. And this is where we are creating an event source object pointing to that endpoint. So it is HTTP based, right? So let's take a look on WebSocket. So this is my simple WebSocket demo. I can just enter my name, join the room. I have joined, online users use general, and I can start typing. So you can see I have joined the room, and this is where I'm started sending the message. So join the room, message. I can leave the room, right? Then I can enter a new name. So you can see I have joined. In the current room is this. So all these WebSocket events. Here client is sending messages, server is sending the the broadcast event back to all the connected clients. Let me just try to join it. So you can see two online users. I am logged in from the two tabs, right? So when user is joining the room using WebSocket, I'm able to receive the other online user also joined, right? This is a simple WebSocket interface to show. I am adding another user, and you can see all the three users on all the three tabs, because the server has broadcasted this join room event, and all the connected clients are able to understand, okay, now there are three users, right? So this is a simple WebSocket demo, and you can start typing the messages now. I think all the messages are going to the group. Here you can see these all have joined the same room, so they can start typing. And whenever you type something here, let's say I'm typing testing knock knock, so it is sending the on message, and here I can see this message. I am able to receive those messages here on all the tabs. So this is like a simple real-time chat where multiple people are joining, and they are receiving all the messages from all the users in this room. So this is a simple demo which talks about, okay, you can join, you can leave, all these events, join events, leave event, and a message event. And here we can see all the logs of all the events, socket events, join room, then message, join room, I left, and join room. So there are three users have joined, user joined, and then you start sending the messages to the room. And to see all the WebSocket interface or exchange messages, we can just go to the socket IO, and here we can see all the events. This is message ID received. I can leave the room, I can join the room again, right? All these events are actually being sent from the client to server and being received. So because here, if you are leaving the room from here, then the leave room success true. The server is sending events to all the participants that this particular user has. So let's say if I create a new room, yes, there are two rooms, right? So all these events have been are being emitted. You can see this is a lightweight thing, and here this is the interface which it is talking to, and these are the payload, and all these props are happening here. So this is like a simple, you can see the interface for WebSocket events. Once the client is connected to the server, all the events will be shown here. So from code perspective, we have to use this WebSocket gateway. Okay, at your gateway.ts, this is a simple file in the app module. We are just using this chat gateway, right? So this chat gateway has these specific methods: subscribe message, all these subscribe. So these are the subscribe message we are doing. Stop typing, get room, all these different events, get users, private message. So whenever you join the room, this particular event handler gets called, and you will just see some welcome message, right? And this user is added to the particular room. So apart from that, I mean, leave room, message, typing message, like whenever you send a message, so what happens to that? This server.to user emit the message. So what it is sending the message sent event with this data success true. This is how this WebSocket and the event server sent events are different with each other. The protocol is different, and the way and their uses, the use case is totally different. But I hope now you understood how they are different, what are the use cases, how you can build a tiny chat app or a server sent event where UI keep showing you the updates based on the event stream which you are sending.